The next task after mapping the requirements is mapping the components. In this task, we decide what are the components that take part in our application, while remembering that a component is an autonomous piece of code that runs in its own process and has its own compute resources. The best way to define the component is to look back at the functional requirements. We see there are three main requirements. 1. Receive status updates from IoT devices. 2. Store these updates for future use. And 3. Allow end users to query the updates and present them with the relevant information. And also, let's remind ourselves the expected load. We are talking here about 500 concurrent messages and 40 concurrent users. Now, there is an important distinction here. We are looking at two completely different tasks, receiving messages and responding to client requests. These two tasks perform separate actions, have different non-functional requirements, and work against separate entities. Because of this, the natural choice here is to separate these two tasks to two separate components. One that is responsible for receiving the messages, let's call it receiver, and one that waits for user requests, which will be called info provider, or simply info, since info provider is a little bit too long. So, two components it is. But wait, that's not all. There is a very important aspect that is hiding here. We know the receiver is going to work under heavy load, 500 concurrent requests. That means that one of the important aspects of the receiver is that it needs to release the message update request as fast as possible, because for every millisecond it works on a specific message, there are more messages waiting to be processed, and we don't want to reach a thread starvation situation. Meaning, the service will not have enough resources to handle the waiting requests, and it will start throwing exceptions. So we need to end the request as fast as possible, but that begs a question. What should be done with the request once it's received? There are basically two options here. First, simply insert the request to a data store as is. No processing or validation is needed, all the messages have the same format, and we all live happily ever after. This, as you can guess, is quite rare. The second option, every message needs to be validated and processed, and just then can be stored for later use. Now, this choice is dictated by the way the IoT devices send their messages. We will need to go to the client and ask her what is the exact format of the messages and what processing is required on them. So let's go ask her. 2 days later, she comes back with the following answer. There are 4 types of IoT devices. Each one of them has its own message format. 3 of them use JSON format, and one, which is an old one, uses a fixed format string. In addition, most of the messages must be validated because the device's software might be buggy, and we cannot trust it blindly. That's going to be fun. So, we now know the receiver has the following tasks. 1. Receive the message, obviously. 2. Validate the message. 3. Parse the message and convert it to a unified format. And 4. Save it to the data store. Let's talk a little on the third task. This task is super important, as it makes our data independent of its source, meaning, when we will query the data, it will always look the same and be of the same format, regardless of its source. No matter from which device the status update was received, the data is fully accessible to the clients, and there is no need to format it while querying. This concept is extremely important in systems that receive data from different sources, each with its own format. The data must be stored in a unified format, regardless of its origin, to allow fast and efficient querying. Okay, so back to the components. Who should perform these tasks? To decide on this, we have to remember that the receiver must release the request as fast as possible, so we wouldn't want it to perform additional tasks. We want it to get the message, save it for later use, and end the request. So the receiver is going to be responsible for receiving the message, and that's all. Who is going to handle the other tasks? Well, obviously not the info service. It has nothing to do with handling incoming messages. It handles only users' requests. So it looks like we are looking here at additional components. Okay, so we have a new component that will handle the validation. Do we want another one to handle the parsing, or will we give this responsibility to the same component? Well, that's a good question, and actually there is no definite answer to it. Some will say that a component must be responsible for one and only one task, and therefore there should be separate components for validation and processing. Others will say that since validation is quite a small task and it's not an atomic one, there is no value for validation if there is no parsing, then they can both be performed by the same component. In this case, I think the latter approach is the right one. Validation and parsing always go hand in hand, and from a higher point of view, they are part of the same service. In addition, any additional component is another process we need to maintain, and there is no justification for this in this specific scenario. So to summarize, we have three components: receiver that receives the message, handler that validates and processes it and then stores it for later use, and info that allows users to query the data. But wait, that's not all. Remember when we talked about logging and monitoring that it's always a good idea to have a central logging service? So let's add one. This service is where all the logs are sent to, and it enables us to have a complete view of the application's activity. This is extremely important, especially in applications like ours, where there are several components and each one has its own responsibility. Using a central logging service gives us a coherent view of all the flows in the system, regardless of the specific components they were run in. Okay, so we have the components of the application. One last thing. Obviously, the status updates should be saved somewhere. We need some kind of data store where the handler will save the parsed updates and the info will be able to query from. So, let's add a data store shared between those services. Okay, great. Next, let's talk about the messaging between them.